Okay, so today we are in part 6 AVF or HVF single field analysis, and today we are going to discuss about raw data and grayscale because there are 10 things in single field analysis, and we have covered three. I don't know, we have covered what? I think two topics, that is demographic data and reliability index. Now we are going to third and fourth, then we will go move fifth, sixth, and other one. So raw data and grayscales. So what is raw data? It's basically exact retinal sensitivity expression decibel unit. Finished. Okay, that's the raw data. So raw data used with the different strategy differ. So always used same strategy for the follow-up. So basically it is raw data from which we derive all the thing, total deviation plots and everything. And from raw data we derive grayscale too. So raw data is basically very important, isn't it? So normally this sign is seen only in front of 0, but if this sign is seen in front of 1 and other, then you must know that the maximum intensity of light projected by the field analyzer is not 1000 apostrophe, because maximum is 1000, but it's less than that. Okay, so if this sign in any other than 0 is indicating that the light is becoming dim and it's time to replace the bulb. So it's very important that whenever you see this kind of greater than 1. Okay, and another point you must understand that visual field threshold declines with age about 0.5 to 1 decibel per decade. Visual field threshold, particular retinal sensitivity degrees. Okay, this is very important. So this is how you see things in raw data. Sometimes this bracketed things is there or sometimes not, and something like that, this is 0. Okay, and sometimes you see these things, you 0, this is very less sensitive area, and the retinal sensitivity is very good at 30, 29 and 30. So see, this is how I have taken this picture from GRAD, that 32 dash 2 pattern is basically, we know 76 points there. So then we have numbers in every 76 points, isn't it? And you see this 0 means this is the, isn't it, that's the blind spot, because blind spot also lies around 15-degree temporarily visual field. So that's the blind spot, isn't it? So this is very important that every point, see this point corresponding to this, isn't it? This point corresponding to this, isn't it? So that's it. This is the uh, what do you call that, beer area, isn't it? So that's the, so you see something like that. So what do you draw from this picture? This, can't you see this upper half is completely bad, which is 0, and visual field in the upper half is like extremely bad, which upper half is low sensitive and lower half is okay, isn't it? So that's the conclusion you can draw. And what you see here is extremely bad, isn't it? And that's how I, what I have told you, that greater than 1 means you come to know that bulb is not doing well and it's time to replace the bulb, isn't it? The bulb is dim and it's time to replace the bulb, or it requires the recalibration. Sometimes you see like that, greater than 1, and sometimes that's greater than 1 is not at all good. It means that bulb is not doing full work. It means that field analyzer is not completely 10,000 units light projection, but 9500 units. So that's how you come to know. So normally this sign is seen only in front of 0. So it's very important whenever you see it, something like this in ball in report, then you discuss with your team. So that's it all about the uh, raw data. Then gray scale, sometimes it's called half tone color scale. Okay, so numerically value from the raw data are presented graphically according to the gray scale form. So gray scale doesn't define diagnosis. Never ever think about this. Gray scale does not define the diagnosis. It only helps doctors to explain the status of the visual field. It only helps doctors to explain the status of the visual field to the patient, especially glaucoma specialist. Okay, so areas of high sensitivity are denoted by lighter shades and are low sensitivity are denoted by darker shades. That's very important. Never ever use grayscale solely for the diagnosis. Never ever. Don't do this. That's definitely going to be an car crash. Don't do this. Okay. We examine 76 or 54, 76 for example, 32 dash, 54 for example, 24 2 dash points, but in grayscale there may be up to 2000 points. So we cannot comprehend. Okay. So for this also, can you see 40 to 50 there is one set, 36 to 40 there is another set, 31 to 40 there is another set. Actually, from 0 to 50 there is 10 categories in which it is divided, isn't it? So conversion of the raw data to grayscale does not involve any statistical calculation or normative data analysis. So that's why grayscale is only to explain for the patient. Grayscale is sometimes we use to show patient that it's progressive, disease is progressive. Sometimes it's quite clear. I have already put the picture in last of my presentation, but it's not about the diagnosis. You cannot make diagnosis from grayscale. It's for uh, basically for a diagrammatic picture, so we can explain to the patients. Okay. So see, isn't it? There is a 10 categories that display. The first 41 to 50 is one, and then every other is 5555 degrees. Distance is 5555 only. 31 to 35, 26 to 30, and that's five space is only for five. So see, in this case, this area is lighter area, isn't it? It has good raw data, and this area has lighter area. It has good raw data. At the same time, this area has zero. This area 5 is a slightly lighter. So that's how it made. Okay. So isn't so from this picture it's quite definite that this point is 27 here and this point is 28 here. So between 27 and 21, which is definitely lies in 25 to 21 category, sorry, 25 to 30 category. So it's very difficult to differentiate that 25 and 29, though they have 4 decibels difference. So 4 decibels difference. So that's why one of the failure of grayscale is it's not calculation cannot be done. Another point is you cannot expect that change is sudden or gradual. For example, sudden. See, if you see 31 to 35 graph, then what do you tell 26 to 30 graph? If there is 30 and if there is 31, there is sharp change in the grayscale, isn't it? Because it falls in 30, it falls in this. So there is no exact mathematical calculations. So you cannot comprehend that two thing. Okay. You cannot say there is a difference in 3 or 4, then you cannot say there is a difference in 1 or 2, because if it falls in another category, it will create a large change in the shadow. So that's the case. Okay. So this is the picture I have put, because this is the same case follow up for 3 times. Can't you see this grayscale now progresses a little bit, visual field effect, now it progresses a little bit, isn't it? So basically what 2003, 2004 and 2006, so the difference between 2003 and 2004 is very less, but difference between 2003 and 2006 is very high, isn't it? In case of grayscale. So grayscale sometimes use uh, to see directly and in a short moment that is there any change in long term or not. But rather than that, grayscale is not at all useful, and don't ever think about doing diagnosis or doing anything interpretation with the grayscale. It's totally bad. But you can comprehend a little bit with the raw data. It's very useful raw data, but grayscale it's not at all reliable for the diagnosis or for doing something with visual field. There is a lot to do with total deviation pattern and pattern deviations. There are a lot to do with global indexes, and there are a lot of things that is very important, but not at all grayscale is very useful for the patient explanation, and grayscale is very important, useful to see long-term changes. If there is something like that 2002 and 2010 two AVFs, and you have seen clear distinction, then you can explain with the help of grayscale that how much this darker area is gone and this darker area is basically growing with time. So it's just for that, not for doing any diagnosis. Okay. So I think that's it. And best book very very good book that Jared, just grab this book and try to read as much as possible. I want to tell you that don't even leave single word from this book. Just read, just eat that book, okay? And second book that you have to eat is this, okay? So Bistan, choose.